All right, we are starting chapter 3. Chapter 3 is all about polynomials, graphing polynomials, and getting more in depth into if something's to the third power, or fourth power, fifth power, what would that look like? What are all the key components of that polynomial, the graph, all that. There's a lot with this chapter. So here we go. The polynomial that I give you up front, let's do number 1 up on top here. It's out of order, obviously. And so if I wanted to put it in standard form means that I need to have the biggest exponent go first and then everything decreasing after that, okay? So standard form is gonna be that the terms, the terms are by degree. So you write the terms by degree in descending order. So that's not zoomed in enough. That's going to be, starting off, 2x to the third minus 4x plus 9. Okay, so now I want to talk about all the details of this. Vocab words, that's what these are. The leading coefficient is going to be the number that's in front of my highest power. So right here, it's to the third degree, cubed. So my leading coefficient is the 2. I have to put it in standard form before I can say what my leading coefficient is. So put it in order first is the point. The number in front of the highest power. And in this case, it's a 2. The abbreviation is LC, leading coefficient. The degree means what's the exponent? What's the power? The largest exponent. So if there's a 2, that's a quadratic. And we know we say squared, right? If it's a 3, that's a cubic degree, but we say cubed. If it's a 4, quartic, Q-U-A-R, you know, like quarter, fourths of something, quartic. But you can say, oh, the polynomial is to the quartic degree. And then when you read it, you'd say, 7x to the 4th. And then 5, that degree is called quintic. Q-U-I-N, 5. Like having a woman that has 5 babies at once is like quintuplets, right? Quin, Q-U-I-N. These are all like the root words. Terms. Each separate thing that's separated by a plus sign or a minus sign, separated by a plus or minus sign. In this example, I have 3 terms. Each separation of, a number and a variable, an exponent, all together is a term. Okay, I'm going to move on. Number 1A, we basically just did that problem. And so this is going to be super easy. We're going to identify, this is like the key features. Remember in graphing how I said, what are the key features of the graph? That's what this is right now. So I'm going to have you do the leading coefficient, the degree, the terms, and we have to actually change it to standard form as well. I would love a volunteer from you. from you. Daniel, give me the standard form. Reed, give me the leading coefficient. Aaron, give me the degree. So was it Reed, Daniel, Aaron? Yep, it was. Okay. Reed, standard form, please.
Two x to the third minus 4x plus 9.
Okay. Then it was Daniel's doing the leading or Aaron's doing the leading? Coefficient. Aaron, you had one, and Daniel, you had one.
Daniel's doing the leading coefficient.
Daniel, thank you. Daniel, what is my leading coefficient?
2.
Yep. And Aaron, what is my degree?
It's cubed.
Cubed.
Cubic.
So it can say cubic, cubed. They're both fine. Vinay, what's my number of terms?
3.
3 terms. Perfect. Let's go to the next one. I'm going to want more volunteers too. Here's 2 more examples. So if you've already volunteered, you're done like for the week. So that's pretty awesome. Robert, Max, and Esther. So Robert, give me the standard form.
Negative 3x 4, like
Negative
4
3,
exponent.
yeah, it's yes to the cork.
Negative 5x third
Yeah.
plus 2x plus 6.
Excellent. Make sure I get you. I got you. Thanks for keeping your hands up, guys, because I'm already like, Reed, you can put your hand down. Vinay, you can put your hand down. Okay, Esther, I was going to have you do one. Leading coefficient?
-3.
It sure is. Degree, Tyler.
I put quartic.
Yeah. 4th degree. Terms. This is, you guys, these are easy points, so get those hands up. Get your hands up. Naomi, what is my terms? How many are there?
4.
4. Good. Perfect. This next one, I'm going to press pause on the video. There's so many of you that have your hands up. Let's do it. Let's do it. So if you've already volunteered, please put your hand down. Mary, Huzaifa, and Colin. Get ready to be called on. Mary, Huzaifa. Just want to make sure I get everybody. Okay. Mary, can you tell me in standard form what my polynomial is?
Oh, okay. It's going to be 2x to the 6th power plus x to the 5th power minus is 3x to the 4th power plus 4x cubed minus 8x.
Woo! You're exactly right. Huzaifa, what's the leading coefficient? And Colin, what's the degree? So Huzaifa first.
The leading coefficient is 2.
It sure is. Colin, what's my degree of my polynomial? What exponent is it to?
6.
Yeah. 6, S-I-X-T-H is same as writing the number 6. Terms, how many are there? Dimitri.
There's 5 terms.
1, 2, 3, 4, 5. Perfect. That's the basics. That's like the easy part. Now, what we're going to talk about next is how does my exponent And how does the fact if I have a positive leading coefficient or a negative leading coefficient, how does that affect what my line looks like? Because we know that linear is an exponent of 1. But as soon as we get an exponent of 2 and 3 and 4 and 5, things change. So what I want to show you is the Desmos website, which, here we go. Okay, here we go. So here's what I've got. The link is in Google Classroom, but you can just look at mine too, whatever you prefer. Right now, I've got, let's bring this back to 1. Straight line, linear, all right? An x to the n. This means that my n is the exponent, and then this second line right here tells me that I've got, like, as I move this blue dot, things will change. So right now we're going to do a positive leading coefficient, x to the n. Now I'm going to press this play button, and I'll zoom out. There we go. And you're going to see what's going to happen when the graph is to the first power, third power, fifth power, seventh. Now, let me zoom in and show you what this looks like. It gets dangerously close. Oh, you can't even, sorry, I don't know if it's going to do it or not. I'm sorry if your mind is like getting really dizzy from this, trying to do this and I can't. My point is that this red line gets super close to the x-axis, but it never touches. Sorry. I know it's like crazy on your, okay, here we go.
What you can do is hold down your cursor on the line and it'll tell you the coordinates.
So like, well, let's see if it works. It's, okay, at this spot right here, it's negative 0.1 comma 0, which means that it's just like super, super close. So now let me press play and so you can see this. What I'm doing, see the 1, 3, 5, 7, 9. So that's what it looks like. And it's a fun animation. Okay. Now, what if I put a negative sign in front? Look what I just did right here with my mouse. I just put a negative sign in front of my leading coefficient, which means that now it used to be going from low to the lower right, up, upper right, high. Now when I put a negative, it switches directions. Now let me press my play button for my animation. So it's facing a different direction, okay? And obviously you know what x squareds look like, okay? It's a parabola, but we are gonna talk about like x to the 4th today. So this is just a fun representation of what does it look like. And Desmos is such a cool website. Us math teachers love it. Love it. Okay. I want to show you a graph first. So let's turn to this page first, because you need to see what I'm talking about when I say positive infinity, negative infinity. Okay. I just want you to look at the x-axis and the y-axis. Okay. If I were to have a line that was up going this direction, the x values are approaching positive numbers, like positive infinity, okay? And if I'm going upward, my y values are approaching positive infinity, up. It's going to the right and up. So to the right and up, and I'm gonna have to do a lot of erasing on this. Right and up, they're both going towards positive, okay? When something's over here and is going down, my x values are going towards positive infinity, but my y value is going towards negative infinity. See that? This is called end behavior. what is the end of my graph going to look like? What is the arrow going to look like? So there's that one. My x points are going to the right, positive 10, 11, 12, and my y value is getting smaller, negative 5, negative 10, negative. Okay, so there's that. What about here? Remember, x is still here. My x values are going to the left towards negative 10, negative 11, negative 12. And then look at the arrow. My y value goes down towards negative infinity. This is my y-axis. So that's what an arrow of downward does. X approaches negative infinity and y approaches negative infinity. Okay, then this direction. My x is going to the left, which means negative 6, negative 7, negative 8, but my y values go up, positive 10, 11, 12, 13. So my x value approaches negative infinity and my y value approaches positive infinity. So that's what I mean when I say positive infinity, negative infinity, etc. Now I'm going to turn back and go to the page before, and I'm going to talk about this lower portion of the page, end behavior. What does the line do? Where does the line go? The arrow at the end of my line. Hold on, let me adjust this. I think that's perfect.